There's a lot of, I think, misconceptions maybe about what object-oriented development is, especially in the PHP community specifically. It's an area where we can learn quite a bit, I think. And so one of the big problems is that PHP is this sort of language that you learn kind of by example. You learn on the web, you learn on your own. They don't teach it in school. There's no PHP class in your computer science program. So you either have people who learn PHP on their own, self-taught programmers, or you have people coming from other languages. And in either case, what you do is you go to php.net, you look at example code, you look at existing commercial apps, open source apps, and you naturally adapt to that style. That is your beginning learning point for PHP. Unfortunately, most of those commercial apps, open source apps, when you get a job and start taking over the application that, for the corporate website, most of them are not done according to what most OO people would consider industry standard OO. And as a result, PHP developers probably have, if not a misconceived notion, an incomplete notion of what object-oriented programming is. I think most PHP people consider object-oriented programming to be using classes for the sake of being reused. I think that encompasses the full definition to most people of what object-oriented programming is. And in fact, using objects, there's very little difference in that than using like global functions, unless you structure things in a certain way. So I provide a definition for object-oriented development that I think is accurate. A method, software development utilizing reusable components, that's most people's definitions in the PHP world, but then append to that within a composed hierarchical system. That's very important. And if you look at the next line, it says, using objects doesn't make program object-oriented. It's the relationship between the objects. It's very important. The way you structure the objects, how they are able to communicate with each other, that is what makes an object-oriented system. And when you have an object-oriented system, you gain tons of benefits with regard to maintainability, scalability, flexibility. All the ilities come from OO for the most part. And PHP software lacks in it terribly. If you have a PHP app and a whole new set of feature requirements comes down, or if paradigm shifts occur in the company, but you're starting OO. So some other definitions. And I apologize to any OO people in the room. I'm going over some basic definitions because without them the rest of the presentation is meaningless. And I'm pretty sure that there's some PHP developers who might not have accurate definitions for these things. So we'll talk about interfaces. Most people describe an interface as a contract, right? What does that mean? Quite simply, an interface tells a class what functions and properties it must implement. So that's the sole purpose of an interface. The reason you use interfaces is to provide standardization so that objects can communicate with each other ignorantly. They don't need to know what the other object is, what type it is, and they're still able to communicate with it. And this gives you things like, if you think of drivers in Windows, right? Think of a video card. Every video card manufacturer has their own driver. They all talk to Windows, the Windows graphic subsystem or whatever, but the manufacturers talk to their video cards in their own proprietary language. And it is with an interface that they, and probably like an adapter design pattern, which we'll talk about a little bit later, that they're able to achieve this. Microsoft publishes an interface and says, here's the interface. And then any graphic developer, any graphic card developer in the world can write a driver for their graphic card. Same concept applies in software development for an interface. The next big one is a class. Everybody uses classes every day, probably largely in ignorance with regard to all the sorts of classes there are and how they're supposed to properly be used. So there's instance classes. These are the classes that everybody uses the majority of the time. Foo equals new bar, where you make instances of a class to create objects. That's an instance class. Two sorts of instance classes, concrete classes and abstract classes. A concrete class, again, 99% of PHP stuff is concrete instance classes. And that is the foo equals new bar, where that object is now fully usable. You instantiate it and you can go off and use it. An abstract class is different than a concrete class because it is not fully implemented. And we'll talk about what implementation means, what that means later. And these are all real generic OO things. We're going to get into some very PHP specific stuff, because PHP is different than other languages with OO for a couple of very specific reasons. One of them, the major one, being that PHP is a loosely typed language. And so as a result, it lends itself to cheating at polymorphism without actually implementing interfaces and things like that. It allows you to kind of sloppily do a lot of things without following proper OO procedure. Static utility classes, really underutilized in the PHP world. These are classes that you don't need to instantiate. And a good example is a math class. And I've given 2 examples here. Here you're instantiating a math class. The reason why it doesn't make sense to instantiate a math class in this sense, this math class, is because there's no difference from instance A to instance B to instance C. There's no properties or attributes that apply to a specific instance that make it unique from another instance. Math is math. And so as a result, why write the extra code? Why use the extra memory? Why convolute things when you can have this instead? This is what many people maybe haven't seen in PHP. This is how you call a static method in PHP, with the colon syntax. And so math is a perfect example. And then abstracts, I talked a little bit about there. They're partially implemented in instance classes. So an abstract class is kind of like half interface, half class, because it partially implements the contract. Let's say, let me give you an example. Let's say you have an interface with 2 methods, method A and method B. An abstract class will have an implementation, for example, method A. So method A would actually do something. Method B would do nothing still. It would still rely on a subclass to inherit from it, or in PHP lingo, to extend it, to then fully implement it and be usable. So you can't instantiate an abstract class. You can instantiate a subclass of an abstract class. So the abstract has to be a base class for instantiation to occur. All right, a few more definitions and then we'll kind of get into some more, hopefully more interesting stuff. An object is an instance of a class. And then a namespace. Another foreign concept to a lot of PHP programmers, because PHP got popular with versions before namespacing occurred. Namespaces, or they're called packages in other languages, they simply provide an organization for your classes, a hierarchical organization for your classes. And you've probably seen a bunch of PHP stuff where, let's say I have a library called evlib. My name's Evan. So evlib, and I have a math class. I don't want to call my class math because PHP has a math class, and Zend has a math class, and everybody else has a math class. And you're going to get what's called a namespace conflict. So a lot of people will prefix their class names, evlib math, and every single class name is prefixed with evlib. The correct way to do it is to create a namespace called evlib, and then you can have your class called simply math. It's kind of like a folder. Think of a namespace as a folder. And so now the fully qualified name for the math class is evlib, and in PHP \math. In most languages it's dot. So namespace, backslash, and you can have sub namespaces, so namespace, 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 class name. Interfaces can belong to packages, classes can belong to packages. So we talk about implementing an interface or implementing an abstract class. Very simply, an interface provides a contract. It says your class has to do these things and it has to possess these properties. So to implement that, what implementation is to put that into action. To say, if you ask me, let's say I have a property called color, you ask me what color I am, I'm going to give you an answer, red. If you tell me to do something, run, I'm going to run. That means I'm going to implement it. Whereas an interface, you tell it to run, it can't do anything. Inheritance. It's called extension. I should have used the word extension here, but in PHP, you use the extends keyword to inherit from a base class. Inheritance is used all the time, but again, just because you're using inheritance doesn't mean you're using OO software. Inheritance in PHP, 9 times out of 10, is used for the purpose of reusing functionality. That's what inheritance is used for in PHP. Because there's no strong typing, so you don't do things like the fact, you don't achieve polymorphism. You don't even try to, and that's where inheritance can become very powerful among other places. So not only for the sake of extending reusable code, but also for the sake of creating standard interfaces, because you can have a base class that your application is aware of or understands how to speak to or talk to, communicate with, and things that inherit from that will speak the same language. So the core application can be unaware of the subclasses, and that gives you great power and flexibility. If you've ever written a really long if statement or a long switch statement or anything like that, you will have benefited from using inheritance in that way. Composition. You can achieve something similar to inheritance with composition. Whereas in inheritance, you have a base class with certain functionality and a subclass that inherits all of that functionality and then adds its own. When you have composition, you have a class, a new class that you create, class A, and within it, you make children of it, class B and C. But the idea is that you take several classes with functionality and you put them together. You're able to have more than one class wrapped, and then you can access those two classes, or 3 or 4, however many classes you want beneath it. But you lose the benefit of the typing unless they both implement the same interface. Inheritance, 9 times out of 10 in the OO world, is what you're going to do. Composition is used in very specific cases. For the facade pattern is a perfect example, and we'll cover that pattern here in a little while. So it brings us to design patterns. So you have the singleton pattern. Singleton, very brief, we'll cover all this stuff, we'll get into detail, but very briefly, singleton means you can only make one instance of a class. It's a little different than a static. There's sometimes in the OO world you argue about when to use a static, when to use a singleton. Statics are useful when you don't want to instantiate it. There's no properties that are specific to an instance, whereas a singleton can contain instance properties. We'll talk more about it later. Facade. A facade is a great big composition. You basically take several classes and offer one big interface for the outside world to talk to all those classes. So all the classes have one point of contact. Imagine a sales team or a company with 50 employees that you need to communicate with. You don't want to ask the graphic designer for the art and the programmer for the code and so on and so forth if you're just the CEO. You want to go to the program manager and be like, hey, the project director, whoever, and be like, I need all of it. And that one person will give you all of it. That's what a facade is. Adapter. Adapter is a class that will translate communication between two classes with non-standard interfaces, right? So an adapter you can think of as a translator. So if I have two classes that this guy speaks Chinese and this guy speaks French, and I speak English, an adapter will take input as English, but output and input on the other side in both French and whatever the other language I said, Spanish. So I only need to speak English always. Chain of responsibility. This is kind of a unique situation one, but it's a cool one. You have a class. The reason why I brought this one up in particular, a couple of these, is because they're very applicable in the MVC world. And MVC is real hot in web development. And so a lot of these patterns can be used as part of MVC to give you great power. And that's why I highlighted these. I meant to bring the book. There's a book called Design Patterns. And they cover all of these patterns and many others. And you can Google all this stuff also. If you just go home and Google design patterns, I mean, there'll be a wiki page with every single known OO design pattern listed. You click on it, it'll give you a chart, it'll be good to go. Chain of responsibility. Let's take a rule-based system, for example. Let's say we have a rule-based system where we can plug in rules to operate on a model, to do whatever to it, to make the price higher or whatever, change the color of it, change properties of it. So we have rules, and we want to be able to add new rules. You know, some things change, we add a new rule based on different criteria, we go down to rule paths. What we can do is take this model and pass it what's called along a chain of responsibility. We give it to rule number 1. And we say, rule number 1, would you like to operate on me? And rule number 1 autonomously analyzes the model and says, do you meet this criteria for me to operate on you? And the model says, through properties and functions, says yes I do or no I don't. And then the rule can operate on that class. If he operates on it or not, he then passes it on to the next rule, and to the next rule, and to the next rule. And so it just goes through every single rule. A rule can choose to operate on the class or not, based on whatever criteria it deems necessary. So this gives you great power, right? Like you write a video game, and the game has capture the flag mode and assassinate mode, right? So in one mode of the game, I want to go get the flag, and then one I want to kill everybody. Well, I have 2 different rules on the game. One says assassinate rule, one is capture the flag rule. I take the model has a property on it called game type, assassin or capture the flag. So a model knows what game type it is. The model goes to the assassin rule. The assassin says, what's your game type? The game model says, I'm capture the flag. The assassin rule says, oh, don't want to deal with you. Passes it on to the next rule, which is capture the flag. The capture the flag rule says, what type of game are you? I'm capture the flag. Oh, okay, perfect. I'm going to operate on you. Let me ask you another question, model. Does this player have the flag? The model says, yes, player A has the flag. The capture the flag rule says game over, and it triggers another flag called game ended within the model, and then it passes the model back to the application, now modified, saying the game's over and player A is the winner. And then say 3 months down the road, all of your users are on a forum and they're like, hey, capture the flag cool and assassin's cool, but I want team games or whatever. I want a different objective. I want an objective where I have to kill this one specific target. So, okay, cool. We don't have to rewrite the system. We don't have to add an if statement. We don't have to do anything. We write a new rule kill my friend.php. We drop it in a bucket, and there you go. You got the new rule in the game without restarting the server, without anything. Just boom, the users go on, they starting their games, they see a new option because you're through reflection, or I usually put mine in a database, but the system's able to say what rules are there, what objectives are there. And then now you have little radio boxes when they start their games to choose a rule, and it automatically uses the correct rule to process that game. And you could have more than one rule operate on the model. So you could have a set of objective rules for the game, but you could also have a set of rules that determine gameplay itself. When I pull the trigger, does 1 bullet come out or does 5 bullets come out? You could have a semi-automatic rule and an automatic rule. And then mix and match those rules to create all these combinations of game types without actually writing a new game engine for every single game type. Extremely powerful. So chain of responsibility is great for plug-in rule-based systems. The observer method. In the web world, it's difficult to see observers and MVC in full action because of the non-connected state of it all, right? But if you're using like a desktop application, Windows application, C# or anything like that, and you can do it in PHP as well, but I'm just explaining why people don't see it so much in PHP or in web applications. An observer, think of let's take an MVC example, and let's take a view. Let's take several views, for example, in an MVC example. One view is like a box that has text that describes the class, and another view is a box that shows a picture that represents the class, right? So you have these 2 views that represent the model. That's what views do. They visually represent a model, right? So I have these 2 views, both representing the same model. And then some guy clicks on the screen and changes the model because he changes the alien's head from red to green because he clicked the radio box that says green. Well, traditionally in PHP, what you would do is you'd say, box 1, the model's now green. Box 2, the model's now green. You'd notify both boxes through code that the alien had changed color, and then they would update their view. This guy would say the alien is now green in box A, and in box B the picture would update with the green-faced alien as opposed to the red-faced alien. So you have, and then let's say you add a new view because you decided you want a headline at the top of the page that says alien color, green or red or whatever. So now you add a new view, but now you have to go back to your code where the guy clicked the radio box and changed the color and have it also update this view. It's tedious, it's cumbersome, and it defeats the entire purpose of MVC. You're just writing procedural code all night long. With the observer method, or the observer pattern, you have this extremely powerful tool where
Each view is what's called an observer, and it subscribes to observable objects. Something is observable because it implements an observable interface, which we talked about earlier. I'll show you diagrams and everything when we get into the specific patterns. So what happens is, when I change the model's observable. When I change the model to green, it fires an event, something that can be foreign in the PHP world. It fires an event saying, my color is now green. And every view that's on the screen that's subscribed to and through this interface, through this common interface, every view that's subscribed to this observable thing is notified immediately, asynchronously, hey, I'm green now, and they all update at the same time. And if you want to add another view, all you do is add another view and subscribe it to that observable object. And then now he will also receive those messages and update accordingly. Observer is hugely powerful, and in the PHP web world, it becomes powerful when you combine it with JavaScript and Ajax, because now you can have real-time updates on the screen as the user does things without ever posting back to the server. I mean, you're posting back, but through Ajax, and you create a very fluid experience for the user, and you give yourself, more importantly, you give yourself maintainability and flexibility. So when the customer or the boss decides they don't like the way this box looks, you can add a box, change the box, do whatever you want to do without touching the engine. And then you have the factory method. The factory method is probably the #1 design pattern used to achieve polymorphism in object-oriented programming. The factory method is basically a class, a static, I use abstract factories. There's 2 different kinds. I'll talk about the abstract factory tonight mostly. You tell it, I want an instance of a class, and these are some things I know about what I want it to be. And then the factory takes that information and gives you the appropriate typed object based on the criteria you give it. And you don't necessarily know the type of the object that it gives you, you only know the interface that it conforms to. So you can communicate with it, but you being the engine or the application are ignorant of it. And this gives you, again, flexibility. I'll take the game example again. Let's say you have, like in a role-playing game world, you have like, like knights and like magicians, right? So those are the 2 classes of players. When you're writing your program, you don't want to say, if user chose knight, X, player equals new knight. Else, if player chose magician, player equals new magician. Because every time you add a new player type or a class, you're going to have to add something to that if statement. And eventually it's going to just become unbearable. It's a poor way to do things. With the factory method, alternately, you tell the factory, the guy clicked this tab that has this word in it, right? And you're just kind of ignorant of the whole thing. It's just magic, magician, or whatever, however you key it. And you pass it off to the factory. And the factory then has the intelligence to give you back the appropriate class. So the only thing you'll ever modify when somebody adds something new is either the factory or the underlying data source for that factory. I usually use a database behind my factories, so that if I want to add a new player type, it's a row in a database, magician. And then I'll give some key to it that corresponds with the GUI, like an ID or something on the form. So when they click on it, it looks at the database, and then the factory is able to determine what's the appropriate class to provide. So whenever I want to provide a new player class, I write the class, magician.php, and I add a row to the database. No if statements, no modification of the engine itself. That's the factory method. Oh, I want to talk about notation briefly, just, I don't know if you can see it really well, because I'll use some of this notation throughout this presentation. I'm not going to get into UML as a whole, it's kind of ridiculous. All I wanted to emphasize here is that arrows up from subclasses to base classes. That's all I wanted, and then scope, negative is private, positive is public. Namespace pollution occurs in PHP all the time. To avoid namespace pollution, don't use the global namespace. Namespace pollution is what I talked about at the beginning of the talk, where everybody's prefixing their stuff, their class names, to avoid conflicts. 10 people have the same class with the same name. You have pollution. Actually, you have collision. Pollution could just be simply one namespace with your whole program in one namespace. So if you look at a class diagram to try to organize your code, or if you're looking at a class tree on your IDE to try to zero in on something, you're basically alphabetically going through every single class in your application. And that is a case of pollution that occurs in 99% of PHP applications that are out there, because they all are derived from PHP 3 and PHP 4 before namespaces existed. It's important that we start using namespaces.
So
Global access in PHP. You know, most people have learned that you don't use the global keyword inside of functions in PHP, so most people don't do that anymore. But they find other creative ways to do the same thing. So there's a few ways to access data globally in PHP while still being clean, organized, and following expected OO protocol. The way I like to do it the most is using statics. I usually have, and I'll give you an example. When do you want global access to something? Configuration stuff. You know, you want access to quickly and you just want it to be a constant or some otherwise globally accessible thing. You don't want to have to pass that around all the time, especially if it's something that's used a lot. You don't want to pass it to every single function, you just want access to it. Back in the day, you put global variable name inside your function and you'd be good to go. The proper way to do it is probably to use what I would do is use a static configuration class. It's very great. You don't have to instantiate it. You define all your config values inside of a static, and you can access it using the double colon syntax that I showed you previously for accessing static methods. You can have static methods and static properties, and statics can be scoped. So you can have, private static members inside of a static class, and then your public members can, operate on those private members before outputting them to the world. So you have all the benefits of instantiable classes, except for you don't have instance properties and functionality. Statics are great for that. Constants, they're used in PHP a lot for text-based configurations, ASCII-based things, non-object sort of things. I guess constants are an accepted norm. Singleton is another great thing, and I have a good example for singleton when it's a good time to use a singleton as opposed to a static. In most web applications, you have a database connection. One database connection that you either globalize or pass around or do whatever. The reason why you'd want to use a singleton for a database connection as opposed to a static is because a database connection is a perfect example of something that does have instance properties. It does have specific properties that make every instance of it different. Because on application A, I might connect to my production database, but on the development version, I want to connect to the development database, for example, right? So there's different properties, different IP address, different username, different password. So there are each instance can have different properties. But within the domain of an application, I only want one instance. Because I'm in the same application, I'm not going to be hitting the prod server and the dev server. I'm either hitting one or the other. So I want a singleton. I can only make one instance of this class, but it does have instance properties, which allows me to make it different depending on my environment or my needs. And then your last option, which actually is something that people hate but is a totally viable option, is to just simply pass them around. That's the right way to do it 9 times. From a purist standpoint, that's often the right way to do it. Then you pass it along to every function that needs to use it. That is a viable way to do it, however, not totally convenient for the developer, and that's why I would suggest a singleton for that. But if you're writing a library that other people are going to use, it makes sense in that case for them to pass it to your calls, because you don't know how often they're using them, or you can't make those, you can't make those assumptions. And that would be an appropriate time to pass things around. And it's important to talk about scope when I'm talking about OO. Why am I talking about scope? Because it is the lack of proper scoping that encourages improper object-oriented development in PHP. The lack of proper scoping and the lack of strong typing, which we'll talk about what that means in a minute. In PHP, you don't define the types of objects when you instantiate it. You don't tell PHP what it is. So foo equals new bar. Foo could also equal new baz. Foo could equal anything it wants to equal in the PHP world. There's no rules. In most traditional OO languages, there are rules saying that you predefine the type that any instance is going to be. So that when I make a foo, my program knows that a foo is always an instance of a bar, always. And if I try to say foo equals new baz, it'll fatal exception. You cannot do that. In PHP, you can do that unless you tell it not to. And there is a way to tell PHP not to allow you to do that. And if you're going to be writing proper OO, I think it's important that you kind of start adapting that habit. And it's called type hinting. We'll talk about that. Let's briefly talk about polymorphism. Polymorphism is the ability to treat one thing in different ways, or to treat multiple things in one ways. And it goes back to this dynamic thing that I'm talking about with code and this ignorance. that your application has of what it's doing. I can create an animal, and that animal can be a sheep, or a dog, or a cat, or a fish, or whatever. I just know it's an animal. I know I can tell it to walk. I know I can tell it to make noise. I can tell it to do certain things. I can ask it how big it is. But I don't know it's a sheep, and I don't really care that it's a sheep. And that is what polymorphism is. So in PHP, you can cheat at polymorphism because you can, without strong typing, you can say anything is anything. And you're not bound by any rules. So that's what PHP developers will do a lot. They'll take a foo, and they'll instantiate one thing, and treat it as such, and then instantiate another thing, and treat it as that. And it's hard-coded, and it lends itself to easy mistakes, because there's no standardized interface. A cat might have a function called speak, or meow, and a dog might have a function called bark, you know, and then here you are writing your code to speak to both of them, and so you end up doing yourself a disservice.
Or you extend something one too many times, you end up with an object that has a meow and a bark.
That's correct. Or you extend something that you don't even know, you just lose track, you know, of what's what. And more importantly, the system loses track of what's what. And it's easy to reuse variables for different purposes. And if you have an IDE that uses what do they call it? Not IntelliSense. What's the generic word for IntelliSense? Code completion. If you have an IDE that does code completion, it's not going to know how to complete your code. And so you're going to be writing it. It's like you might as well use Notepad, you know? When you take away strong typing, you really take away a lot from yourself. You also give yourself a lot. People like loose typing because you give yourself great power. Has anybody ever put they're called variable variables or something like that in PHP, where you put the name of a class in a variable, and then
dollar sign, name.
Right,
I've
okay.
seen it, but I've never-
Without strong typing, that's an unpredictable situation. You don't know the interface of what you're creating necessarily. It's just hard-coded. It'll work if you go through and make sure it works, but there's no guarantee. There's no guarantee. There's no contract. That's what a contract is. It's a guarantee. That's one of the benefits of strict typing. You get predictable usage of dynamic classes. So how do you enforce types in PHP if it's loosely typed? Type hinting is a way to enforce types in PHP. I'll show you what that is. When you have a function, you know, and you have your arguments inside parentheses, you're allowed to tell PHP what those argument types are expected to be. That's called type hinting. I'll show you that. You can use interfaces and base classes. If something is implementing an interface, then it gives you a certain amount of guarantee in terms of the type. And then the third way, which I didn't write down here, is using it's called PHP doc, and most PHP itself doesn't recognize it, but your IDE will recognize it, and it'll give you great power when you're writing your application as far as code completion and trees, class trees, and things like that. It'll give you a great deal of power. PHP doc is just certain comments that you can put in your code according to certain syntax that makes your IDE and other things aware. A lot of test suites will use them as well. That'll make them aware of meta information about your application or other information, useful information about your application. The iAnimal interface. I've kind of made references to it here tonight. This is a contract. It defines how to interact with any class that claims to implement it. Simple. Any class that implements iAnimal must have a function called speak and must have a function called move. Here's a class that implements iAnimal called dog. Very simple. It's just a class. You'll notice the namespace on all of these. This is how you put a class into a namespace in PHP. You'll notice the implements keyword. This is how you implement an interface in PHP. You'll notice it has a speak function and a move function. Had it not had both these functions, you'd get a fatal exception. Your program would not run. So it gives you kind of a checks and balances. PHP is a non-compiled language. In compiled languages, we have this great thing called compiler checks, where the compiler goes through your entire program and finds these problems and tells you about them. So it ensures that you're writing clean code and you know where everything is at. PHP lacks the benefit of being a compiled language, so there's no compile time checks. However, by following proper structure, it will give you many of those checks, and this is one of those ways to do it. I could have implemented only speak, and for move, I could have left the implementation off the same way as I did for the interface and put a semicolon right there, and that would turn dog into an abstract class. We talked about earlier being partially implemented. That would be partially implemented. It has one method, but for the other method, it just gives the interface. It gives the contract, the same as the interface did. It gives you the signature. This is called a signature. So it gives you the signature, but not the implementation. So you would not be able to instantiate dog in that case, but you would be able to derive from it, to be a subclass of it, to inherit from it, to extend it. Dog,
Fish,
right?
and then ask it to move, but it doesn't, rather than doing nothing for move, actually have it throw an exception.
Oh, you mean on the when I talked about the abstract?
Yeah.
So but then it would be implemented, right? If I put this throw new exception not implemented, which is what we do in C# a lot, you have not implemented exception, but this would no longer be an abstract then. It would be.
Oh, that's why you.
It would be a fully implemented class at that point.
The difference would be, at the point at which you tried to instantiate a variable based on dog, your application would fail. Later, with the alternative, you could instantiate dog.
Exactly.
And you could use it up until the point in which you may or may not use the move function, in which case it's more fatal, it's more final, but it's also more predictable that it will fail at instantiation versus some point later.
100% accurate. That's exactly correct. All right, here's another class. Oh, maybe I didn't point out. The implementation, on this one, the dog says arf arf, right? So if I create this through a factory pattern, I would say factory, give me an animal. The factory would give me an animal. I don't know if it's a dog or a fish. I just tell it speak. And if it's a dog, it's going to say arf arf. If it's a fish, it's going to say the fish makes a noise that sounds like bubbles. I didn't know how to write that. So you have this. So I don't need to know if it's a fish or a dog. I just tell the animal to make a noise, and the appropriate animal makes the appropriate noise. Think of a kid's game where they get to choose a fish or a dog, and they click a button that says speak. They click speak. Through radio buttons, they had already chosen their animals, and through association with an ID on the radio button to your database, you were able to instantiate the right class while your application was ignorant the whole time. Kid presses speak, the animal makes the right noise. And also on move, the fish swims to the destination, whereas the dog walks to the destination. Very simple. And then I'll show you a subclass of dog to take the chain just a little bit further. I made a specific breed of dog, a pit bull. So when the pit bull speaks, the dog yells a booming ruff ruff. Now notice, there is no move function here. But this will succeed. Why? Because this is a subclass. This is not implementing an interface. This is a subclass of dog. So this pit bull inherited the dog's functionality. It inherited that functionality. If I had not put speak function here, this would still work, but the pit bull would say arf arf. Because I put the speak function, the pit bull is going to override that arf arf and give a booming ruff ruff. But when the pit bull moves, it's going to walk, the same as the dog walked, because the pit bull inherited the dog's walking behavior. Yes, sir?
And going back to our previous talk about abstract classes, you would implement the move in this case
Yes.
without necessarily needing to implement speak, and it would work equally fine because you would get speak, but you would have to implement move.
That's correct.
You wouldn't have to implement speak.
That's correct. If we had gone the abstract route with the dog class, that's exactly correct.
You have to implement move here.
Exactly. That's
If it was an
exactly
abstract.
correct. That's exactly right.
Implement case.
All right, so pit bull is a subclass of dog, and dog is the base class for pit bull. And in this case, dog is also the superclass. So here's an example of a very pseudo example. You know, it's funny because this is an example of the examples that are on like PHP.net that discourage OO use. But in any language, in any even Java or C#, the examples are always procedural examples for the sake of simplicity. They're meant to be taken by a software engineer and then implemented into a system. And so these examples are equally procedural. I gave this example for a few reasons. One, to show the dynamic instantiation of a class. I just say new animal type. I get the animal type from user. It could be a fish, a dog, I have no idea what it is, I don't care. I just instantiate a new $ animal type, right? Dynamic instantiation. And then I have a function called, and then I call doAnimalAction, which is this function, and I pass to it my animal. And the action is to speak and then to move to the living room. If we were to run this code on a dog, it would say arf arf, the dog walked to the living room. If we did it on a fish, it would say bubble bubble, the fish swam to the living room. I give an example of type hinting right here. Everybody see this? Not something you see in PHP at all. So this is a great example. I don't know it's a dog, I don't know it's a sheep, but I do know for a fact it conforms to the iAnimal contract. I know that because I'm told that. And PHP knows that because you've type hinted it. And if you tried to pass something that was not an iAnimal to this function, PHP would throw an exception. So this gives you strong typing. Type hinting only works with custom classes. You can't type hint that it's a string or an integer or anything like that. It kind of sucks. But in terms of polymorphism for your object schema, yes, you can achieve strong typing, and it's very powerful. This is a diagram I pulled off the internet. I thought it might be good to look at somebody else's instead of mine. I won't even comment on it. You can look at it. Just note that the negative sign means it's a private. The positive sign means it's a public. The way a singleton works is you make its constructor private. So nobody can construct a singleton. Nobody can instantiate a singleton. You have to tell the singleton, you have to call a static method called getInstance. So the singleton is allowed to create an instance of himself, and so he will assure that only one of him ever gets created. And the only way to get that instance is to call a static method called getInstance. Or, I mean, you can call it whatever you want, but this is a very typical method.
I've looked at that 100 times and never understood it, not mental. So.
And the database connection example that I gave earlier was a perfect time to use a singleton. Here's the facade. We talked about composition, and I told you I'd have a facade example later to highlight composition. So here's an example of just two callers, caller 1 and caller 1, genius. It's supposed to be 1 and 2, making calls to 3 different classes, right? And each class, let's say, has a couple of methods or whatever. So you get this web. You know, caller 1 has to call A, B, and C. Caller 2 has to call A, B, and C. With a facade, caller 1 makes 1 call to the facade. Caller 2 can make 1 call. Anybody can make 1 call to the facade, and the facade acts as a kind of a wrapper to all of these classes. Usually the diagram, these should be inside of the facade, I guess, but this illustrated it better. So the reason I illustrated it this way is to show that these guys can access these guys indirectly through the facade. And the idea of a facade is to create a unified interface to a bunch of things, which makes things cleaner, a lot easier. Think of your facade being like a database abstraction layer, for example, and to think of using dynamic classes to have where you could talk to Oracle or MySQL or ODBC or whatever you wanted to. And then so you could make your calls to the facade, and the facade would be able to then interface with the correct underlying data source. That's an example, but it applies with anything. Chain of responsibility I talked to you about, I think, plenty. I didn't draw a diagram for it. Yeah, this was the rule, the game rule.
where you pass the model from rule to rule. I think we covered it thoroughly.
The abstract factory. A class can be concrete and static. So an instance class can have static methods. Does that make sense? I can have a class that I instantiate, like, let me see, let me give an example that'd be better. Animal. The dog. I can have a dog class where, you know, object equals new dog. But that dog class can also have static methods on it, like, for example, total count, total dog count. So for every time I instantiate a dog, there could be a static counter that increments 1, and then I could ask the dog, I could say dog : total dog count, and it wouldn't be referencing any specific instance. It would be a static method on that instance class. And that's how you have to implement the abstract factory. This class is an abstract class that creates a contract for its subclasses, but it also has a static method called getMyClass. And this is what we talked about earlier, where the guy, like, the user tells us what kind of animal he wants, right? So the user would click a radio button. We have 3 radio buttons: fish, dog, and pig. And fish is 1, dog is 2, and pig is 3, and those correspond to IDs in a database, and the database rows line those numbers up with a specific class: dog.php, fish.php, pig.php. So the user clicks pig, that number value comes to the application, and I pass that on to the abstract class and say, getMyClass 1. And the abstract class knows to go look at the database and say, oh, 1's a pig. I'm going to do an instance of pig.php, which is one of these guys, and give it back to you. But pig.php implements this abstract, which is iAnimal. All right, or animal base is what it would be probably called. But when you start using the factory method, you're able to achieve polymorphism. Polymorphism is what you're trying to achieve with often what you're trying to achieve with object-oriented software. And the factory method and the abstract factory are the things that you want to use to provide that. You can read here. It abstracts the process of instantiating classes and thus shields the application from knowledge of underlying data types. It's exactly what it does, or data. Any questions?
Here, I've got another one.
Thank you.
Mine's more of just start a fake question. So, various people have said, I think Brendan Eich, Peter Norvig, and Paul Graham have said that, let's see, what's the quote, that design patterns are basically indicators that the language you're using isn't powerful enough. So, have you encountered any of that, or what are your thoughts on that kind of thing?
Yeah, I have a great deal of thoughts on that. So, and PHP is a great example. Java is another great example to go right with that quote. PHP is written in that is where you don't need design patterns. PHP is that powerful language. You have loose typing, you have prototyping, you have all of these things that you can get away with. And so you have that power. PHP is a perfect example of one of those languages where you don't need to use design patterns. They're exactly right. That's my answer. They're correct. If you have a powerful language, you don't need to use design patterns. And that's the problem. That's the problem. You do it your way, you do it your way, you do it your way, you do it your way. Everybody does it their own way. They are 100% correct, sir.
Well, I think they're arguing too that with a lot of these languages, what you end up writing and implementing as a design pattern of some sort, writing code for that, some of these other languages already have that built in, so then you don't have every other person basically re-implementing the design pattern in the language or in some library or something else to accomplish.
I would argue that that's not what they mean, and if it is what they mean, then I'd like to get them in a room for about 30 minutes. I think that's just horribly inaccurate. I don't think a language can implement a design pattern. That doesn't make sense. They can give you a framework, you know. They can give you the MVC framework like Microsoft does, or you know, Symfony gives you frameworks. This Cake probably gives you frameworks. You know, what's a framework? A framework is exactly that. It's a bunch of rules, holes you can fill in the blanks, and then you have what you want to achieve. But how can they implement the design pattern? I mean, that doesn't make sense because they don't know what your implementation is, right? I mean...
So one of the quotes here was, don't want to get off on a big tangent.
Oh no, this is great, man. Art, this is the best way to go about it.
Paul Graham wrote this: the shape of a program should reflect only the problem it needs to solve. Any other regularity in the code is a sign, to me at least, that I'm using abstractions that aren't powerful enough. Often that I'm generating by hand the expansions of some macro that I need to write. Of course, he's a Lisp programmer, so that's why he says macro.
And he's living in a university.
And yeah, I would disagree. And here's the bottom line. When I talk about OOPHP, I talk about it in contrast, in stark contrast to the establishment. And so when you follow design patterns, you should treat the exact problem. That's correct. And what's beautiful about design patterns is they treat specific problems that you have encountered before and you will encounter again in software. So if you're using the wrong design pattern for the wrong thing, bad. Or if you're bending a design pattern for something that it's not meant to be solving, bad. Usually a proper software architecture will be a combination of many design patterns to create a full system, and you'll create the relationship between those patterns to be your application. That's what makes it yours and what makes it valuable versus the next guy, and it's why you can't just buy stuff off the box that does everything. So there's still plenty of room to be programming. But I am of this kind of school of thought that I don't want to write low-level code, and I don't think I should, nor should anybody, because it's prone to mistakes and it avoids standardization. It's like Windows back in the day before every toolbar looked the same. It's just, or when people use different graphic tools, use a Java app on Windows, and then use a Windows app on Windows, and or maybe 2 years ago before the Java people got the look and feel right stuff, and they looked different. Nobody wanted to use a Java app on Windows because it didn't look like the Windows app. And so, you know, there is a time for being creative. There's a time for programming. But it's not 1965. We have to reuse, we talk about reusable things. We talk about scalability, maintainability. Agile is hot as fire. People want agile software development teams. They want to write in iterations. They want to write prototypes and then from that prototype derive a product. These are things you can't do effectively and on budget, as every PHP programmer knows, because they've all failed at this specific, budgets and times. It doesn't happen most of the time, and it's because we insist on being these artsy, I want to do it my way, be creative, have full power, full flexibility. That is the problem with PHP, I believe. That this is important to the PHP community, and I think we can just really change. You go to companies that are like Java companies or .NET companies or whatever, and PHP is like the inferior. I was at a company consulting for a company, and they were switching everything to .NET because they were bringing themselves up to industry strength or something, and I was just like, what do you mean? You can do everything in PHP that you can do in .NET. It doesn't make any sense. But it's a stigma that goes with PHP, and that stigma is based on improper use of the language, in my opinion. So I hope if you take nothing else away from that, it's just that. And if you just can study this stuff on your own when you write your own programs, because it ends up out there in the wild when the next guy comes along and takes your job or whatever, your code ends up out there and ends up being an example to somebody, and start writing beautiful code and getting paid more money because we have this knowledge that's valuable. Thank you guys.